to my channel Technology for Noobs, and in this video I have a very interesting topic. So I was working on one project where I needed to train a neural network model which consisted of pre-processing a text data, meaning creating a word embeddings of those, and train a model out of it. Now the challenge which came while doing that was my system's RAM was not enough to process all the text whatever I had to train the model. Then the question arises how to do it, and this is where I found the answer. And the easiest way, if you are in a situation where you cannot fit all your data in a memory and then train a model out of it, you, instead of doing a complete training on the complete set of data, do it in a batch process. So this batch process is not the batch size of which I am talking about. This is very specific way of training a model where you do not pass the entire data at once, but you pass the data in chunks, and then the weights get recalculated after every pass, and then this is your one set of complete batch, meaning a complete epoch where you have a single pass of the entire data to that model, and then you do it again by shuffling again. So this is the entire process. So let's have a look of it as an example. So to create an example, I am working on this one particular data set which is in the Kaggle natural language processing with disaster tweets. So you can get the data from here. I know the data is not enough, but I would be able to create a scenario which will show the in practical that my RAM is not sufficient enough to process it, and hence I would need to do it in a batch. So there are many ways of doing the batch process, or there are many ways of doing the neural network training. Either you can use TensorFlow, either you can use PyTorch, or you can use Keras. So in all the frameworks, the same logic will be used. What I'm going to do in Keras is specific because I found many users are still using Keras as their base framework to train. And in this Keras, in my system, I'm using PyTorch and as well as TensorFlow as a backend, but at present I would be using the Keras API to do the training. Okay, so let's have a look into what are the things which I have done. So I have imported my libraries pandas, numpy, and I'm using ChromaDB utils where there is a support for embedding functions, and I will also show you how I can do it using the TensorFlow. So this embedding function actually uses PyTorch as a backend. So all the codes, whatever modules are there, it's dependent on the PyTorch. So you need to install that as well. Keras, sequential, dense, and input. Okay, let me explain you the dataset first. So this dataset consists of train, test, and sample. But in the data, you have ID, and then you have a text, you have a location, keyword, and target. So this data is about somebody has posted in the Twitter that okay, I'm in a some place where there is a natural calamity or disaster happened, and the task is whether they are the genuine people who are talking about the disaster, or they are just saying something but it does not relate to disaster as such, right? So our task is to identify whether a given tweet is a disaster or not, and that's all about the data, right? So as I can see here already, it has ID. Okay, let's look into it in the notebook. So there are only 7,000 rows, but in real scenario you could have a large amount of data, right? And our main objective is not to learn about training, but our objective is to learn if you have a memory constrained resource and you need to do the training, right? So let's not deviate from it, but yeah. So this is how my data looks like. So most of the times keyword doesn't have much, location doesn't have much, I have only text, and I have target. The best way to create any model is either you do a TF-ID word vectors, you create something and you do it. The other best way right now at today's scenario is you take any word embeddings, or you take any LLM model, create a word embeddings out of it, and just train your model on those word embeddings, and you already have a target as 1 and 0. So I just simply did a quick search how many ones I have. So out of 7613, I have 3271, which is fair enough. So I don't need to worry about any imbalance in the dataset. From SQL model selection, I just simply splitted my data, training part and validation part. And then now it's the time to calculate the word embed or to calculate the word embeddings for each sentence which I have got or each tweet which I have got. So which is in the text. The simplest way, as I said earlier, I have imported a very simple sentence transformer embedding function. This has a very small LM model which returns a 384 size of embedding for given input. So once I pass all this sentence to it, so let me do it. So now I'm able to do this. So here all the embeddings are now stored in the feature X-train, and how many values I sent. So I sent around 5329 sentences, and it was able to calculate the word embeddings out of it. So not a big challenge. See here I have it. It's a list of all the embeddings, right? So I don't need to see much. Now if you need to see something how I actually did it, so sentence word embedding, and if I pass any text, for example text, it calculated the word embedding. So this is what has happened. And if I check how many element values are there, so 384 as I said. So similarly I have to calculate the, okay, there is one interesting thing which I need to show you. So if you see the resource consume around 10 GB, which is, I still have some space after calculating the embeddings, which is fine. Now I will calculate the embeddings for, so this is my label for the other thing. Now this is, I am calculating the embeddings for my validation dataset. I executed it, and as you can see here, so it's all happening in the CPU RAM right now. I am not using the GPU, which I have it, but I'm not using it right now. Okay, so it's already calculated. Now I have my set of data already prepared. So 5329 cross 384, 2284, 384. This is my X variables now. I mean just X part of the data, and then I similarly have created my labels. So which is my Y part of the data. Now if I have to train a model, I will just simply create a Keras model using the sequential API. My first, then I am giving an input where the length would be 384, which I've stored in the ELM length variable. Then I will add another layer called dense. So this depends on user to user, but a simple increasing the dense layer, then decreasing the dense layer, then similarly decreasing, and then last layer which is activated by a sigmoid, which gets me my binary with zeros probabilities, right? 0 to 1. So all those things are there. There's nothing fancy here, and then I just simply train my. So this is how my structure look like. Now if I have to train my model, I need to get my data in the right shape, which I have done here. And this is the final shape of my data. So 5329384, 53291. So this is my X, this is my Y, this is my validation X, this is my validation Y. Now this is the main part now. So what options do I have to train model now? So I have an option which is .fit. So if I will do .fit, I will pass my variables. I will say, okay, what is the batch size? I have epochs, verbose, and then validation part, and it will be able to do it. The reason it will be able to do it, I have still a lot of space here. My data is already in memory, and all the things would happen here. So what advantages which I get when I do .fit is, my available RAM is enough to do the training. That was first. The another is, when I do the model.fit, it would be super fast because everything is in memory, right? All the shuffling, waffling, everything which Keras take care or this model API takes care would happen automatically inside. So we don't need to break our head on doing all those stuff, right? So this is the whole reason why you would use .fit. Now if I do it, it would be faster. So I'm doing it for 50 epochs. As you can see, it's happening too fast, right? So one epoch is my model is able to see the entire data in one pass, and 32 batch size is nothing but at a time 32 samples are being passed through that model, but all the data gets passed through on each single epoch. So do not get confused with that. So I am able to train the model. That is what I wanted to establish here with my available GPU which I have. With my available RAM which I have. So my model training is done. So once I have this model, I can just simply say model.predict, and I can pass my validation data or any data which you feel like, and it will be able to predict for you. So I got my predictions. Now let's change our approach. Okay, now I need to create a scenario where the system is not able to do the processing of it. So for this scenario, now I will restart my kernel. Now focus here clearly. Okay, so I am not gonna use this particular way of calculating the word embeddings. So what I'm gonna do is I'm gonna make it more resource hungry approach. So what I'm gonna do is I will have a BERT model, the default BERT model, and here it will return a size of around 784, and it is too much memory consuming. So I will have that as another approach for calculating the embeddings. Okay, I have my training data, I have my data and blah blah, and I will split my data. Then I have so this is where I have to calculate the embeddings. So I will show you once. So this particular function, if I pass some text, so it is able to calculate the embeddings of the size of 768. Okay, it seemed fast, but to do it for the entire data at one go, which is keeping everything in memory only. So if I execute this and we watch here, so as you can see, my memory consumption jumped like anything. Now there is not much memory which I have, and eventually it will break. So before it happens, I will stop this process. So I believe you understood the scenario where my memory consumption will be too much and the processing of the data cannot be handled. So on this scenario, what I will be doing is, so I have my training data and validation data all in place, which I have, and let's go into another API which Keras provide, and that's called train on batch. So there are certain scenarios where I would want to use this. So one is very specific, clearly stated. If I do not have much memory available in my system, but I still want to do the training, I would use the train on batch. There are certain other functionalities or some other different neural network training where you would want, like training a RLs or LSTM models, right? All those models, there you want to reset your weights sometime. So you cannot do that on the model.fit. Then you need this train on batch where you can do those resetting of the weights at some point of time, right? Reinforcement learning approaches. So what I would be doing now, I will explain you in specific. As you have seen, I am able to calculate the embeddings by passing any text to this particular function. So what I would be doing is, instead of thinking of sending all the data at once to my model.fit or a process data at once, what I will be doing is, I will select a batch size, I will do the calculation of I will do the processing, and then I will pass that subset of the data to that model. Then I will loop over again, I will get the next set of batch, I will do the pre-processing, and then I will do the training again. So as simple as that. So this is what I have written here. So I have selected a batch size of 50. I chunked my number of data into the number of batches which I would need to pass. And then epoch is, again I will repeat, one epoch means entire data is passed to your model. A single batch means a small set of data or subset of the data which is passed to the model to learn. So I will run a loop which says, okay, get me the batch of data, calculate the features or pre-process it, and then pass it on to my model. So in this model, the same model which I had earlier, I will do a train on batch and I will pass my values here. So I have my 768 length of my embeddings, which I will train it here. Then I have my new set of model, which is a bigger model. Then I will. So now what is happening is, at each pass, a batch of 50 samples is being passed to my model, and that would become my first epoch. Now as you can see already, earlier I was not able to process the entire data at once, but I can process a small chunk of the data in my system. And this is where this train on batch actually comes in handy. A person should not be worried about this is taking too much time or this is not optimum. Yes, it is not optimum. But the advantage which you are able to get is, if you know the right set of hyperparameters for your model, which you can identify by a small batch of the data, and then later on the final model has always to be trained on the complete set of the data, the neural networks. So this is where this process comes in handy and saves your life or saves your day by getting stuck of thinking that you cannot process all the data in your system. I hope you learned about it, and if you have any questions, please feel free to write it down or reach out to me. I will be happy to discuss that. This is all about this particular video, and thanks for your time. And if you like it, if you learned something, then consider liking this video and subscribing to my channel. Thank you again and have a great day.